This is lesson 1.3, day 1, distance and midpoint. So we have 2 days within this one unit. So some stuff we're going to kind of skip around on, and then we'll have that in our day 2 video. So first we're going to talk about distance. So distance on a number line, distance in coordinate plane is what we're going to then move into. But basically distance is the difference between the 2 points, and it's the absolute value. So from this point to this point, and most of us here can just kind of count or see, but the difference of -6 and -3 is -3, which is a distance of 3. So distance is always positive, never negative. So that's kind of why we do the absolute value. So in this next one from A to X, if you want to try that one on your own, you can. Do the difference of -5 and 3, and then find the absolute value, or you can also count. And that is 8. So now we get into distance in the coordinate plane, or with our distance formula, which you've seen in the past. And without focusing so much on which is x and which is y and what do we subtract, and basically we're going to be finding the difference of our x values, squaring them, finding the difference of our y values, squaring them, and then doing the square root of that sum. So I really want you to more focus on adding these values together and or subtracting these values in whichever order makes the most sense to you. Most of the time people like to take the first and then subtract the second. So we're finding the difference, just like we've been doing. So the difference of those two squared plus the difference of our y's squared. And making sure that when we do the difference and we have a negative, that we have both our difference and our negative, which end up becoming a double negative or changing to a positive. And then we take our square root of our sum after we have simplified. So this is -9 squared. Be careful when you type this into your calculator. Make sure that your -9 is either in parentheses, or you remember that a negative squared is always positive. And then here, -5 squared, so it's not -25, it is 25. And then we want to add those values together and do the square root of that, which ends up giving us the square root of 106, which is 10.3. So let's try this one on your own. You're going to subtract your x's, square them, subtract your y's and square them, and then add them together. Make sure they're both positive values, and then do the square root. And hopefully you got 7.3 for your answer for letter B. So now what we can do is we can check graphically with Pythagorean theorem. What is Pythagorean theorem? Well, we just got done using that, a squared plus b squared equals c squared. And so we are going to plot, and I'm just going to do this first example, plotting c and d on my coordinate plane. So -4, -6, and there's c, and then d is over here at 5, -1. And so we are going to turn this into a triangle. We want this distance here. So we are going to go straight down and straight across, and we can see that our legs, we can just count, that's 5 and that's 9. So if we take 5 squared plus 9 squared, those are our legs, we can find our hypotenuse, which is our CD squared. So we take and we add these together, 25 plus 81, and that equals our CD squared. So we have to do the square root, which the sum is 106. And so when we square root, look at that, square root of 106, square root of 106. We added 81 and we added 25. That is exactly what we have here with Pythagorean theorem. So CD is 10.3, just like what we got up here. So it's basically Pythagorean theorem using the legs to help us find that hypotenuse. So midpoint is the point halfway between the endpoints of a segment. So the point halfway between the endpoints of a segment. So midpoint is where we are going to basically find the average, adding up the x's and dividing by 2. And for both the x value and then adding up the y's and dividing by 2. So we're going to do this first example for day 1, and then we're going to leave the next few. We're going to tackle that in day 2, that video. All right, so Marco places a couch so that its end is perpendicular and 2.5 feet away from the wall. The couch is 90 inches wide. How far is the midpoint of the couch back from the wall in feet? So first step, we need to change that 90 inches into feet. Since we're talking about feet here, we can't have inches here and feet here. So 90 divided by 12 is 7.5 feet. Okay, so we are going to take our 2.5 plus our, so I drew a little visual here. Here's our wall, here's our couch. We're 2.5 feet away, and then our couch is 7.5 feet long. So that would make our total length all the way to this point 10, because 2.5 plus 7.5, we are 10 feet away from the wall. So we are going to add our points to figure out what our middle point would be. So adding up our beginning and our end and dividing by 2, and that would make us 6.25 feet from the wall. So again, we'll tackle these in day 2 here. Let's go ahead and jump to some midpoint questions here. We've got a picture given to us already labeled. If it doesn't give you a picture, definitely draw a picture and label it. So when something is the midpoint, we know it's in the middle, which would make this side equal to this side. So if this is 6 minus 3x, this is 6 minus 3x. So now what we're going to do is we're going to take and use our addition postulate where we add this side plus this side equals the total. Okay? So a segment bisector bisects a segment right in half. Okay? Like we're sharing a candy bar. We got to be nice and we got to only cut it directly down the middle. So 6 minus 3x plus another 6 minus 3x is going to equal the total, which in this case is 14x plus 2. So over here, we're going to combine like terms. That's the 6 and the 6, which is going to make 12. The negative 3x and the negative 3x, which is negative 6x. And that is going to equal our 14x plus 2. I like to get rid of the smaller variable, which is the negative 6x. So we're going to add 6x. So 12 is equal to 20x plus 2. And then we are going to finish solving by subtracting 2. And 10 is equal to 20x, which when we divide by 20 is going to give us a half, or 0.5. So it asks, find the measure of PQ, that segment. So we need to plug this back in to find the measure of PQ, which is 6 minus 3 times x, which we now know x. So we're going to plug in the half. And so it's 6 minus 1.5, which would make it 4.5 for PQ. Okay. All right, so let's take a look at our next example, which is the last example here. And I would like for you to try this one on your own. It's just like the last one. So again, if it's bisecting or it's the midpoint, we know that this side is equal to this side. So we can also write that in there and then combine these two sides to add it up to give it to the total and then solve. So try this one and then check when you're ready. All right, so 2a minus 1 plus 2a minus 1 is going to be equal to 3a plus 1. So combining our like terms over here, and then we want to subtract 3a, and then add 2. A is equal to 3, which means if we're trying to find the measure of AC, we want to plug it, oops, I plugged it into the wrong one. Catching my mistake right here. So for AC, AC is the entire length, so I need to change this to be, let's fix this now, 3a plus 1. So it's a 3 and then a plus 1 for AC, the entire length. So 3 times 3, 9, 9 plus 1, 10 is the entire length of AC. So don't forget to fill out your thinking questions.